Okay, so hopefully everyone can see my current slide. So my name is Tiffany Jernigan. I am a developer advocate for pretty much everything related to containers on AWS at Amazon. So right now I'm going to basically go into an introduction of AWS Fargate and also start talking about some parts of the security. Okay, so Nate was just talking about how there's containers and how they make it easier to build your applications. So for building cloud-native applications, containers have been extremely useful. You can easily scale them, you can send them to other people, and basically it just makes it easier to break up your applications. So people started needing ways to manage large clusters of instances and containers. So say if you are running your containers on AWS and you were running them on EC2, for instance, and you have more than 5 containers, having to deal with scaling that yourself can be pretty tedious. So to solve that issue, we created Amazon Elastic Container Service. It's a cluster management system, and it's hosted as a service. So basically, it handles your scheduling, your orchestration for you, cluster management. You have the option to use placement, and it has a task placement engine as well. Though that only solves part of the issue. So you now have cluster management, but what about having to worry about updating your operating system? What about having to update Docker Engine or the ECS agent and having to do this on every single one of your instances? That can be a lot. So say if you're looking at each instance, if you look at just one, you can fix it for a few. But say if you have to fix it for maybe 200 instances or so, that will be pretty tedious. So we decided to help solve this issue. So if you look at things beforehand, we have Amazon ECS, and it does the scheduling, et cetera. So then we decided to create AWS Fargate. So Fargate basically abstracts away all of the underlying infrastructure. So you don't have to worry about, am I at the right version anymore? It is handled directly, it's handled for you. So to quickly introduce Fargate, basically, it's managed by AWS. You don't have to worry about EC2 instances anymore. You can just start worrying about the things that you need to create your containers. It's elastic, so you can easily scale up and scale down. So if you want to have 3 more versions of 3 more containers, then you can easily do so. And then it's also integrated with the existing AWS ecosystem. So there's VPC networking, load balancing, IAM, et cetera. And basically, the things that you could have done before with ECS, like the API that you use is the same as what you use in Fargate. You just can use some different options. So let's look a bit into some of the ECS or Fargate primitives. So first, we have the concept of a task definition. So a task definition is basically a template in JSON that has up to 10 containers in it. So you can give information such as what are the container names, how much CPU memory do I need, and different things that you would set up for it, such as ports, et cetera. So first you register that task definition, which you need in order to create a task. Next, we have the concept of a cluster. So basically, it is an isolation boundary. So you can give it specific IAM permissions, you can give it specific VPC networking permissions for it, and create your cluster. So within that cluster, you can then run your task. So it's basically an instantiation of your task definition. And then instead of using EC2 mode, you would use Fargate as the launch type. There's also the option of being able to create a service. So basically, for services, unlike running a task, you can choose how many you want as your desired count. So if you want to have 2 copies of your task running, it will ensure that even if one fails, it'll start up another one. And then you can also attach that with a load balancer for your service. So basically, as I mentioned, the task definition schema is the same. You can use your ECS APIs to launch your Fargate containers, and if you want to migrate from EC2 to Fargate or Fargate to EC2, it's pretty easy, especially since you can have them both on the same cluster. So let's look a little bit into what a task definition is. So here's a little snippet of a specific task definition for running Nginx. So you give it a family, which is the name of your task. Then you give your container definitions. So for this one, it's just pulling Nginx. And so you can have up to 10 in each task, and they all are located on the same host. So each container can talk to another over localhost. And so you can do things like name, image, URL, mount points, volumes, etc. So there's also CloudFormation support. I'm not sure who's actually used CloudFormation before, but basically with CloudFormation, you can use concepts such as your task definition, you can create your VPC, you can create your subnets, and have it all in one or multiple CloudFormation template files and launch that. So some of the options you can use basically are, with the API, you can go use the AWS console, you can use the AWS CLI, and then with either of those, you can then use a template with CloudFormation as well. So let's dive a bit into compute. So for CPU and memory. So for Fargate tasks, you have to define a task level of CPU and memory. If you've used EC2 before, you may know that you get to choose a specific type of instance. Say, do I want T2 micro? And with each of those instance types, there's a specific amount of CPU and memory. And since we're no longer dealing with instances here, you instead decide how much CPU and memory does each task need. So this can also result in, say, if you were underutilizing an instance before, now you can more easily use the extent of what you might need. There's also the concept of task level resources. So you can, within there, you can also give the entire task. So you can give the task CPU and memory, but you can also give each container CPU and memory. And then the billing for that is per second on what you use. If you look online, there's a pricing schema, which is dependent on how much CPU and how much memory you're using. And one moment while I grab my water. Okay, so now you might be wondering, okay, so what are some things that I can, how does the whole idea of storage work? So with Fargate, you can use EBS-backed non-persistent storage. So basically, it can be used as like your application scratch base. So when your task terminates, then your storage also does too. And then there's Docker layer storage as well. And then I had mentioned earlier on that we have load balancing. So with Fargate, there are two different types of load balancers that you can use. You can use an application load balancer or a network load balancer. We also have ECS managed service discovery. So basically, you don't have to, if you can decide, do I want to use a load balancer, do I want to use a load balancer and or service discovery, depending on what your needs are. So you don't have to necessarily create a load balancer if all you're trying to do is find another service. So basically, this helps make it so it's high availability and you can easily scale with it as well. So Nate, earlier he mentioned that we have ECR. So let's talk a little bit about container registries. So with Fargate, we support private registries, public registries, such as like Docker Hub, and then if you saw anytime recently, we introduced private registry authentication. So basically, this means that if you are trying to use a private registry outside of ECR, you can give your registry in Secrets Manager, which is, so it's another AWS service. So in Secrets Manager, you end up giving the registry's username and password, and then it will use, the task definition will use that to be able to pull from your repository. And in order to be able to do that, you need to create a task execution role. And I will talk a little bit about what a task execution role is a little bit later. But basically, that role will need permissions so that ECS has the ability to actually get the secret value. So that slide is in the wrong place. Don't mind that. OK, so some security concerns that people worry about. OK, so I have to worry about, is my network secure? Do I have the right permissions to be able to access what I need? Can I run the commands that I need to describe something, to create something? How do I deal with secrets? And then there's also the concept of, I want to make sure that my images are secure. There's image scanning. And then dealing with all the other pieces of making sure that your application is secure. Nate had also mentioned a bit earlier about the idea of where we try to make sure that everything on our end is secure, and then you as customers are responsible for making sure that your application is secure as well. So let's first talk a bit about networking. So earlier I had mentioned creating a cluster. So when you create a cluster, you have to give it or create a new VPC. And so VPC is virtual private cloud. So basically, you choose the networking mode. So when you are trying to start with ECS, you have the option of, when you create the cluster, do I want to use Fargate or do I want EC2? And then you can have it create a VPC and then also have it create subnets as well. And if you don't know what subnets are, basically each availability zone has a subnet per region. So these tasks, they run in your VPC and your subnets, and you can configure security groups basically for how you want to control the traffic. And if you have, for your subnets, you have the options of making them either public subnets or private subnets. And depending on how you want to interact with that, use a load balancer with it as well. So if you look into the VPC, so you have your Fargate task. So basically, it'll end up attaching an ENI for every single task that you have. And each task will end up getting its own IP address. And then you can determine how that you want that to be visible and connected to. So you could have part of your application running in a private subnet. Say if you have a database and you don't want people to have access to it, and you want to have the web server public, so you can have them interact with each other that way. And then you can also integrate that with, say, load balancers. So with your load balancers, you have the option of either having them be internet-facing or for them to be internal only. So say if you have an internet-facing ELB. So basically, that would be what I was kind of just mentioning. So you would have your public subnet, and with that subnet, you would have a public IP address. And then you could create the security group, and with that security group, you can tell it, say, I want to be able to have access from port 80 if I am using something like a web server. And then you would have your tasks actually running in the private subnet. And then you can you can make it so that the load balancer can actually get traffic from that security group, so that way you don't have everything accessible to everyone on the internet, but just the things that you want to share. So with configuration for VPCs, so if you've used ECS with EC2 mode before, you may have left it at bridge mode. A while ago, we had added the option of AWS VPC. So basically, that's what enables the ENI creation and attachment to your task. So that way you can have IP address, et cetera, for every single task that you have. Whereas before, if you're using an EC2 instance, then you would have one IP address, and that would be for your entire instance. So if you wanted to have multiple tasks, and you had different containers on those trying to go to port 80. Well, you would have to change the host port, otherwise they would interact with each other. Whereas now, if you have, say, 3 different copies of a task running of Nginx, then you don't have to worry about that, because the host port and the container port they end up being the same, but it's specific to that IP address that's created for every single one of your tasks. So you can use this like in the console, or if you want to use the AWS CLI, you specify a network configuration. You give it AWS VPC mode, which for Fargate, you can't use any other type of networking mode besides AWS VPC. And then you provide it, okay, what subnets do I want it to include for that VPC? We also have IAM. So that's Identity Access Management. So with Fargate, we have several different types of permission tiers. So we have a cluster. So with the cluster, you can basically decide, okay, who can access this cluster? Who can launch a task? I can make it so that my friend or I can create another user and have that user have permissions to be able to just see things but not be able to edit it, and give that user access to, say, one of my friends. There's also the task role. So basically, the task role makes it so that ECS can actually access some of these other resources and for it to be secure, instead of having it. That way you actually give it the permissions to be able to do things for you. We also have the concept of a task execution role, which I had mentioned a little bit earlier. So this one, basically, it allows you to do things such as pulling from private registries. So say if you were using a secrets manager with a private registry, or if you used ECR, or if you want to create CloudWatch logs and push to CloudWatch logs, you need to set that all up. Basically, it's things that you want ECS to do on your behalf. And then for the task role, it would be things that your task needs specific access to, such as a specific database or so. So if you kind of look at that, there's your cluster permissions, you have your task role, and then you have your task execution role. So let's take a quick look to see kind of what some of this stuff looks like over in the console. Okay, so hopefully everybody can kind of see my screen at the moment. So the first thing, if you go to services, you just go to Elastic Container Service. So the first thing that you would do is you would create the cluster. So say if I go to create cluster, here's where you have the option of, do I want it to be network only, so Fargate, do I want it to be using EC2 instances with Linux, or do I want it with Windows? So I want Fargate, so then I would click next. And then I can give it some sort of cluster name. So if I want to since this is for EkoSystem Day, I can just call it EkoSystem, or whatever I feel like doing. So here's where I was mentioning that you can create a VPC if you want. So here you click Create New VPC. You can choose what CIDR block you want. You can give it specific subnets, and then these will create public subnets. If you want to do, you can also go and say use CloudFormation and then add your own private subnets as well. So, and you can add more subnets if you want. So these would each go with a specific availability zone. So if I just go and click Create, so then what it does is it creates the cluster, and then it also creates a CloudFormation stack with what it does to create that cluster. So say if you want to repeat the exact same thing or use it and give it to someone else or build on it, you can just go over to CloudFormation. So if I were to just click console again, if I look at CloudFormation, then I can just see here, there's the ecosystem that is currently being created. And if I go and look at that stack, you can see what resources it's creating and see the status of that. So now if I go back over to ECS, I can create a task definition. So here you also have the option, do I want it in Fargate EC2? Some tasks, depending on how you create them, say if they're both if it's using AWS VPC mode, and you set up giving like the task CPU memory, you can use some of the same tasks both in Fargate or EC2 mode. So the first part here is to give it a name. So say if I want to just call it, I'll just call it Eco because why not? So for the task that I'm going to be using, I don't need a specific task role. I do need a task execution IAM role if I want to be able to pull from ECR or log to CloudWatch, for instance, or pulling from any private registry. I'm just going to use Docker Hub for this one. And for the execution role, well, if you want to look at what that is, you can have it create it for you. So actually, if you have never used Fargate before, or if you look at the top of this screen for when you go, so if you go to clusters, there's an option that's for get started, and it will walk you through how to use Fargate, and it will set up all the infrastructure that you need, including any of the execution roles for you, which you can modify depending on what you need. So say with the private registry, if I want to add my secrets manager, to put that ARN in there, then I can modify my task execution role. So then if I want to give a task memory, say if I want to give it a gig, and then 0.25 of vCPU. Then you can also add a container. Also, if someone gives you a JSON file, you can just use the JSON and configure it via JSON. But I'll go here and add a container. So say if I want to call my container, I can just call it EkoSystem. So I'm going to pull from my own registry. So I have a task called space, which hopefully still works. But here's where you have the option of using private repository authentication. So if you click that, you have the secrets manager ARN. So basically for creating that, you would start in secrets manager, and you would create a new secret there, giving it username and password. So if I exit that, so then you can also have the option of giving the specific container what memory for the container, what port mappings. For mine, it will be port 80 since it's the way my web service is set up. And then if you take a look down here, there's the option of essential, and basically you have to have at least one essential container in a task, and if your essential container dies, then your entire task will. You can do things like entry point and give it a command, environment variables, and then if you look down over in their storage and logging. So by default, if you use the console, you can have it auto-configure CloudWatch logs. So here it's going to create my logs group and all the things inside of that. And this is one of the things I need that execution role for. So I'll add that. I'll create it. So now I can go view my task. So you can look at the builder, or you can look at the JSON. So basically, you can just see how everything is set up, what the different values are. So you can run a test two different ways. So either you can start, say, in my cluster. So if I go to EkoSystem. So here you can see, as I mentioned earlier, that you can have Fargate and EC2 in here. So you can have your instances, which are container instances, and then you can also run things with Fargate. So you can either create a service, create a task in here, or you can start directly from your task definitions. So say if I am over here and I want to create a service. So then I can give it the launch type of Fargate. Then I would pick the task definition that I just created, give it and it has the cluster ecosystem already. And then I'll just call it EkoService. And then you can choose, okay, how many tasks do I want? So say if I want to have 5 copies of a task running, and it will make sure that I actually have 5 running. If one fails, it'll start another one up. So say if I just make it 2. So here, you can then pick what your cluster VPC is. So just to verify, if we take a look at our CloudFormation template. If I click on EkoSystem, you can see outputs, you can see all of the different resources created, and it's 0, 1, 2, 3, conveniently. So then here, you can just double check, but since we started over there, so there's 0, 1, 2, 3. So then here you can see the 2 subnets that we ended up creating, and you can see that they're public. So it created it in 2B and 2A. So I could pick to put in just 1, but I'm going to pick it to be in 2 for high availability. Then you can have service security groups. So by default, it'll create one, and it'll be for port 80. So you can also add other restrictions there. Say if you're using MySQL and you want to have access to port 3306. You can add all those things here, and if you have existing security groups, such as if you run through the Fargate tutorial, you can just click select existing security group and pick that one. I'm just going to create a new one. So then you also have the option, okay, so do I want to have a public IP for this task or not? So do I want people to be able to go and just directly access the IP address and go to the port? Then we also have the concept of health check grace periods. So for having this, you need to be able to, you need a load balancer. So if you want, you can either go and create a load balancer, an application, network, etc. So say if I quickly, I'll just show how it works. So if I go over to EC2, then if I click load balancers, I can go and create a new load balancer. So I can do application load balancer, or I could do network load balancer. So say if I want to load balance my application, I'm very unique with my names. So I can make it internet facing or internal. So I want it to be on port 80. I can add a listener here if I want to add another one, but since I only have port 80, I just need that one. And then it has the VPC, and I want it on these 2 subnets. And with the load balancer for application load balancers, you have to make sure that you have at least 2 different subnets for it to load balance over. So then you can create new security groups, use existing ones. So then if I want to configure the routing, you can create a target group. So the target group, basically, you'll give it port 80, and then that target group is how the load balancer will know where it's trying to get what it's trying to access. So if I name it EkoTG, so then I have the option HTTP, and it's port 80. So with Fargate, since there's no concept of instances, you need to use an IP address. So then you'd give it an IP, and then you can add other health check settings. So if I go register targets, so here, that's the network that I have, and then port 80. So then I can create that. Cool. So now here, if I go here and I click application load balancer, you can see there's EkoLB, and then I click add. I already have one, so I will use that, and I'll have that target group. And then you can also have service discovery and DNS, and then you can go and click next. If I forgot something. Okay, so let's see. 80. There we go. I missed clicking the target group. Okay, so auto scaling, create service. So then if I go here and view, you can see the details, you can see what the target group is, what the port is, how many, and then you can see now it's trying to provision 2 copies of the task. So what it'll go and do is pull down that container from Docker Hub, and then it'll start provisioning the task, and then it'll move to pending. And the goal is for it to end up being running. So it'll take a little bit of time since it's trying to set up everything that is needed, all the ENI, et cetera, for actually being able to have your task as running. So once that actually finishes, in order to be able to look at it, so if you go look at your load balancer, there is a DNS name. So you would use that DNS name and go to that. So next it's activating. And you can actually jump into one of the tasks and see, okay, what's last status, what's desired status, ENI, and everything else with that. And if you didn't use load balancer, you could also, well, either way with that, if you have it as public, you can go and use the public IP. So if I refresh again, it says it's running, so let's hope the demo gods like me. And they don't, of course. Well, I don't know what I did wrong specifically with my load balancer. I believe that might be the security group, and then actually changing that to make sure that it has the correct access. So if I look at that security group as inbound access, outbound, yeah, we'll have to debug that later. But if you look specifically at it, you can see that it is running. Okay, so if we go back over here, okay, so now I'm going to introduce my co-host, Justin Graham. He is the manager for basically developer advocacy and outbound types of things for containers.
Thanks, Tiffany. Great job on the demo.
Thank you. I'll have to debug the issue later. It always happens whenever it's a live demo.
Demo gremlins aside.
So yeah,